Hello, welcome. We are in Chapter 5, Part 2, and in this video we're going to be going through the introduction to the Quadrus method. The Quadrus method is one of the methods that we're going to learn to help us solve quadratic equations. Now, this prefix quad, we'll just want to note means square. And so as we start talking about this method, we're actually going to start by just looking at some multiplication and some area, as well as symmetry, because these two ideas of multiplication relating to area and symmetry are going to help us with the Quadrus method. So one thing we want to think about is mathematicians will always pause and think to avoid hard work, meaning we like to look for shortcuts. So if we're going to multiply 37 by 23, we could kind of think of this in the traditional method where you probably learned in elementary school. You would stack 37 and 23, and then you would multiply 7 times 3 is 21, carry the 2, 3 times 3 is 9, plus 2 would be 11. We put a 0 and then do the same thing. 2 times 7 is 14. We carry the 1. 2 times 3 is 6, plus 1 is 7. And then we would add and we would get 851. However, we could also think about this in the context of area. Now, if I have a rectangle and we were to think about that rectangle as 37 by 23, then multiplying 37 times 23 would actually give us the area of this rectangle. However, it's again a little bit tricky for me to multiply 37 by 23 in my head without using a calculator. So I'm actually going to change the 37 and the 23 into easier numbers to work with. So instead of thinking of it as 37, I'm actually going to think of it as 30 plus 7. And instead of 23, I'll think of it as 20 plus 3. And this side would still be 37, and this side would still be 23. But when I split and kind of think of those two separate portions, if this piece was 30, and this piece was 7, and this piece was 20, and this piece was 3, we could actually multiply each of those individual pieces. This is kind of similar to the box method. If you've seen the box method with multiplying polynomials, this would be really similar to that idea. So we could multiply 20 times 30, which is pretty easy to do in my head. That would be 6. 2 times 3 is 6, so we just add those two zeros. 20 times 7 would be 140. 3 times 30 is 90, and 3 times 7 is 21. And then we would just be adding those things together. So I'd be adding 600 plus 140, which would be 740, plus 90, which would be 830, plus 21, which would be 851. Now, if we were going to compute 23 by 37, it would be the same process because it doesn't really matter which side is which. This rectangle, whether we do 37 by 23 or 23 by 37, we should get the same answer. So for multiplication in general, what we know is that order doesn't matter. It doesn't matter which number we multiply first, as long as we're multiplying. Let's take a look at just another example of that. So if I was going to use this area model to compute 211 times 32, again, if I were to think about my rectangle as having a side of 211 and 32, but again, 211 isn't easy for me to multiply. So I'm going to break that up into easier chunks. For example, I could think of this as 200. And then even the 11, I'm going to break up into 10 and 1. So the 200 and 11. And 32, I'll break up into 30 and 2. And then again, we could just multiply a piece for each of those values. 200 times 30 would be 6,000. We would keep all three zeros. 30 times 10 would be 300, and 30 times 1 would be 30. 200 times 2 would be 400. 2 times 10 would be 20, and 2 times 1 would be 2. Now, when I go to add, I'll add my 6,000 plus, and I'll go ahead and just combine my 100s together and my 10s together. So if we combine 400 plus 300 would be 700, 20 plus 30 would be 50, and then 2. So we would have 6,752. Now, we could do a similar part when we have polynomials. It's going to be the same idea. If I had a rectangle and I wanted to think of my area for multiplying these, I would just have variables instead of numbers, but I could still have the 2x squared plus x plus 1, and we could still have the 3x plus 2, and then we're just, again, dividing up that side into each of those portions so that we can multiply. 3x times 2x squared, 3 times 2 would be 6, and we would get x cubed because we're adding. 1 plus 2 would be 3. 3x times x would be 3x squared. 3x times 1 would be 3x. 2 times 2x squared would be 4x squared. 2 times x would be 2x, and 2 times 1 would be 2. Writing my answer, I could keep the 6x cubed. We could combine the squareds, so that would give us 7x squared if we added those. We could combine the x's. That would give us 5x, and then the 2. And we can't really combine anything else together, so that would just be my answer. Now, if we look at how these are related, one of the things that I notice is we have a 6 and a 6, a 7 and a 7, a 5 and a 5, a 2 and a 2. So when we kind of split things up, it's kind of similar whether we do a polynomial or numbers. So we could say the digits are the same in each. Now, the last thing that we're going to take a look at is symmetry. And when we're talking about something being symmetric, that means it would be exactly the same on all sides, or it would be identical, or we could cut it in half and get the same piece. So if I have a rectangle and I know the area of the rectangle is 36, the question is, what do we know about this rectangle? We would know if the area is 36 that the sides have to multiply to 36, but that's pretty much all we would know. There's not really much because we don't know any information about the sides. For example, the sides could be 36 and 1, because 36 times 1 would be 36, or they could be 3 times 12, or they could be 6 times 6, or they could be 9 times 4, or they could be 18 times 2. We have a lot of options for what the sides could be. We don't really know because we don't know any information about those sides. However, if we have a symmetric rectangle, meaning all the sides are the same, really that means we have a square, and if we have a square, that means the sides would have to be 6. Because we would need one number that if we multiply by itself, we would get 36. So the side lengths would have to be 6. The point we should take away from that is symmetry is our friend. We like symmetric things because having symmetric things actually tell us more information about the shape itself.